All right, so where we left off last class is we had kind of talked about doing these frequency distributions for qualitative variables, right? So we had the cause of death, which was just a word, right? So this was kind of how we built our frequency distribution. But then said we could kind of use those different responses as well as either the percent frequency or just the regular frequency to kind of create this bar graph, right? Using either one of those as our y-axis values. So today what we're going to do is how do we do the same thing but for qualitative variables? Okay. So I have a little bit of stuff to say, and then we'll kind of probably jump into Excel pretty quick here today. So we have pie graphs as well. So can I do this with quantitative variables as well? It's actually pretty easy. So think about first if we had a discrete variable. This really is going to be almost identical to what we did last class with qualitative variables. So before, I looked through this huge data set and I counted the number of times the cause of death came from cancer. The number of times that the cause of death was diabetes or whatever the other causes were. Well, let's say instead I had a data set with a number of kids in a household. It's the same process. All I would do is go through, count the number of kids who had, the number of households that had 0 kids, write that number down, that's my frequency. The number of households with 2 kids, did I skip one? 0 kids, then count the number that have 1 kid, count the number that have 2, count the number that have 3. I would then have all these different possible responses and their frequencies. Well, now it's just like I was doing with the qualitative variable. Instead of putting heart disease, drawing a bar up to the frequency, I would just put 0 kids, draw a bar up to whatever the frequency is. So discrete data provides no additional challenges to us, right? We're still just counting the number of times we see each possible response. Just in this case, instead of causes of death, it would be just the number of kids, different possible responses I could see there. Now, with continuous data, we have a bit of a problem, right? So let's think about if I wanted to do an income distribution, right? And I've got this huge data set of income values for people in the United States. And I said, okay, I'm going to go through and count the frequency for all the different possible possible responses I could see. So I go through, count the number of people who make $0 a year, count the number of people who make 1 cent, count the number of people who make 2 cents, count the number of people who make 3 cents, all the way up to whatever Jeff Bezos makes, right? That is going to be the most insanely long, run the length of the campus, that graph, right? That doesn't seem very practical. So what we're going to do is we're going to take this continuous variable and we're going to create these bins, and we're going to force the data, I shouldn't say force the data, but we're going to kind of, compress the data into these bins. Okay? So the example this would be for the income, instead of counting every possible income value's frequency, I'll get the frequency for the number of people who make between $0 and $20,000. And then the number of people who make between $20,000 and $40,000. Number of people who make between 40 and 60, so on and so forth. Now I'll have a smaller number of bins, and maybe I have the length of my distribution, my frequency distribution, once I'm graphing it, looks a little bit more reasonable. Right? So we're going to create these bins, or sometimes like the book will call them classes. I will almost 99% of the time call them bins. That's just the terminology I kind of default to. But once we have these bins, now it goes back to exactly what we were doing before. Take the $0 to $20,000 category, draw a bar up to whatever the frequency is for the number of observations in between that range of values. Okay. Now, when we create these bins, we need to be careful. So the way that I just said it was a little bit lazy and then sloppy, right? Because what could be a problem? If I have bins that go from 0 to 20,000 and 20,000 to 40,000, what happens if the income's exactly equal to 20,000? It would get counted in 2 bins. I don't want that to happen, right? It should be that every observation only belongs in 1 bin, which is, in just a second, I'll come back to this, which is the idea of being mutually exclusive. So we need to make sure that our bins are mutually exclusive, or that any value would only be counted in 1 bin. Now, when we do the work in Excel, I'll kind of show you, how this would look in practice as we're working through it. But ultimately, it becomes important that when we're looking at the minimum and maximum of these bins, the equality is only on so I do 0 to 20,000. I need to make sure that it's greater than 0, less than or equal to 20,000. Then my next bin, I need to make sure I don't include the equality, right? So the next bin would be, is it greater than 20,000 or less than or equal to 40,000? And then the next bin, greater than 40,000, less than or equal to 60, so on and so forth. That was like, I kind of jumped ahead a little bit there. But when we create this kind of bar graph, right? Once I have my bins and I kind of want to plot my frequencies, that bar graph we would give a special name to, which is a histogram. So all that terminology does is identifies that, yeah, this is just a bar graph, but to get these categories, we originally had continuous data that we had to force into these bins. Okay? I want to turn those tables around. You know, I didn't even realize that they were like that. Sorry. So once we have this histogram, right, it really is going to look no different than what we had before. Okay. So how many bins or classes do we choose? Well, this is kind of up to us. Like in a homework assignment or something like that, you would be told how many that you want to create. But in practice, it's really choosing something between 5 and 20. Right? The whole reason we were creating these bins is so that we didn't have a graph that was like too wide. So going over 20 kind of defeats the purpose. Right? The whole point is we're trying to get a more succinct kind of graph. If we go less than 5, it's not very interesting if I say I'm going to count the number of people who make income between 0 and 500,000, and anybody who makes above 500,000. That's not a very interesting graph. It doesn't tell me much about the distribution. So I'm probably going to need more than 5 or more bins, but I probably don't want to go over 20. Okay. Excuse me. There's no set rule. It's kind of up to us. Like I said, you'll be told in the problem. Now, how do I choose those bin lengths? Like I was using $20,000 as my bin length, right? 0 to 20, 20 to 40. Why did I choose that? Well, I chose it as just an example, but the way you would actually find the optimal number is to use this formula, right? So you would take the minimum value and the maximum value. You would take the difference between the two, which would essentially tell you the range of values that you have, right? If my minimum and maximum were, 500 and 600, well, the range of values I have would only be 100 there. I'll then take that range and divide it by the number of bins that I want to have to tell me kind of what the length of each bin should be. So this is the optimal bin length formula, and we'll use this usually as kind of a starting point. Right? I don't think we'll completely get through it today. I'll probably show you an example just where we use this optimal bin length formula. But in practice, what we'll probably do is use this as a starting point, because sometimes this ends up being a number like 32 or 58.15758. Well, that doesn't look very nice and clean on a graph when we're creating these cutoffs for the bins that have several decimals associated with them. They're not really nice round numbers. So a lot of the times we'll use this as a starting point, and maybe we get like, 11,459. Well, we're just going to create bins of 12,000, right? We'll choose like a nice round kind of number because it's going to look visually a lot better on the graph, right? That's the whole reason we're doing this, is to eventually get kind of a nice graph to convey this information about the distribution of the variable. Some other rules we want to make sure. We already talked about the mutually exclusive idea that every observation is only going to be counted in one bin. We also want to make sure that it's exhaustive. So in the income example, we might get caught up and say, okay, we'll do bin lengths of 50,000. So how many people make between 0 and 50, greater than 50, but less than or equal to 100? And we do that, but we stop at like $500,000. Well, the problem is there's going to be people who make more than $500,000 that aren't going to be captured, right? So to be exhaustive, a lot of the times what we'll do is maybe I do these $50,000 bins for income. And then my last category, I say anybody who makes greater than 500,000, right? I kind of create one of these catch-all categories to ensure that I'm capturing if I continue to do $50,000 bins out to whatever, Bezos or Musk are making, it didn't really solve the issue or solve the problem. However, I know that past $500,000, it's a pretty small, right? There's a pretty low number of people kind of making annual salaries over that amount, right? So I might create kind of this catch-all category at the end. And there could be situations where I want it at the beginning, like maybe the bulk of the data, like when I was looking at, we'll look at birth data in this class. And, most pregnancies, the length is like on the right side of the distribution, like they're kind of around 9 months or predominantly around the months surrounding that. Right, we know we have a lot of premature births as well. So maybe there, our catch-all category would actually be kind of on the lower values. That's not all, that's not a lot of examples where you probably want the catch-all category at the bottom, but there are some where it would make sense, right? I think more often than not, to make sure we're being exhaustive, sometimes we'll have these catch-all categories at the very top of the higher values. We also want to try as best as we can to keep the lengths the same. So you don't want to do something like, I said we might want to choose a nice round number. I don't want to do something like 0 to 20,000, 20 to 30, 30 to 75. I don't want to have my bin lengths jumping all over the place. I want to try to keep them the same, with the exception of these kind of catch-all categories sometimes at the end. Okay. Questions? All right, so, I won't be using online quizzes this week, but next Wednesday, I'll have our first one after class. But just to give another example of kind of how these will play out, is we might work through an example like this in class, and then I would give you a very similar one in the online quiz, maybe change the numbers a little bit, right? So this one hopefully is very easy. Like once I have this formula, right? Let's say I had, wanted to do this frequency distribution for average SAT scores at a bunch of different Indiana high schools, but I want to create 9 bins, right? So I know the maximum average SAT score of these schools is 648, the minimum is 352. How would I come up with the optimal bin length? Right? Well, all I'm going to do there is take my maximum of 648, subtract that minimum of 342, whatever that difference is, divide it by the number of bins I want of 9, and I get about 32.88. Right? Now, I'm rounding it up here. I'm only showing you integer values. So if we were kind of working through this one in class, I probably would show you the 32.88. But, right, if the answers are all integers, you would kind of round your answer to the nearest integer, which in this case would be 33. Now, in practice, if you're ever not using that exact optimal bin length, right, so I don't use 32.88, what's going to be a problem if instead I don't round it up, but I round it down to like 32? What's going to happen for my 9 bins? They won't be exhaustive because why? So essentially what this optimal bin length calculator is doing is say, look, if you had a range of values of 100 and you wanted 10 bins, what should the length of every bin be to fill out that entire space? So a range of values of 100, you want 10 bins. You would need 10 bins of length 10, right, to fill that out. So if you ever made that bin just a little bit shorter, what's going to happen is you wouldn't actually capture the maximum value. Okay? So anytime you don't use the exact number here that the optimal bin length formula gives you, you need to make sure you're pushing it up. So even if this was 32.1, you would want to just push that up to the next nearest integer of 33 if you wanted to choose kind of a nice clean number with no decimals associated with it. Okay. So I think from here, all the rest of these slides up to here, and this eventually will be where we're going to get to. But these are just kind of reference slides. As we work through the Excel examples, we'll kind of go through all this. So these are references. We're not going to necessarily have to go through them. We will instead jump into Excel and see how we do this. So up on Canvas, if we go to the Files tab, in-class data, and we open this enrollment blank file, okay? So I'm going to start out assuming that you know absolutely nothing about Excel, all right? So we look at, open a file in Excel, we would call this, like just terminology, is the workbook, right? And then down here, we've got a bunch of different worksheets. So I was, lazy, I guess, and didn't name this one, but sheet 3, we'll probably work with this on Wednesday. Sheet 1 and 2, this is a data set that's got a school identifier, the school's name or university's name. And then here, if I click on the cell, even though I can't see it, up here in the formula bar, it tells me everything that's in that cell. So this column represents the total number of undergraduates, essentially, the grand total number of undergraduates at these different universities. Okay. It's got the state associated with them as well, right? So I've got 4 different variables here, and I've got quite a few observations. If I scroll down, you can see this is a pretty big data set, right? So I won't show the whole thing to you right now. Now, we're not going to deal with this worksheet today. I'm going to just choose a smaller subset of these to work with, right? So go to that Indiana worksheet, and I basically just pulled out all the universities that were in Indiana. Same variables, right? Total number of undergraduates, state abbreviation, which is just Indiana here. And I'm going to make this larger so you can see what I'm doing. So we're going to try to build one of these frequency distributions for this continuous variable, right? Now, technically, this is kind of a discrete, right? We've got jumps. If we had a discrete variable that had a wide enough range of values, we would still probably have to do something like create these bins, right? So even though I said specifically it's for continuous variables, it could be for a discrete variable if it's a wide enough range of values, right? If I could see anything from 0, 1, 2, 3, all the way up to 100,000, well, I still have to force that into bins. That doing 0 to 100,000 would be an insanely wide graph, right? So I've got this undergraduate enrollment. I'm going to first try to find my optimal bin length. Now, a couple of things I'll show you before that is notice we've got column and row kind of headings here. So every cell is identified by that column and row. So this would be cell E3. Okay. So E3, if I put the word, a word in here, just type a word in. One thing that I can do in Excel, and we'll kind of see how we can exploit this today, is I can use something called cell references. Okay? So a cell reference, anytime I want to use one, I have to start out with an equal sign. Right? Putting an equal sign in Excel tells it that you're going to have it do some math or a built-in function that it already has built into it. So for example, I could do equal sign 2 plus 2, and we'll do the math for me. I could do multiplication like this. I could do division, subtraction, right? Whatever kind of mathematical. I could basically use this to be a calculator, right? But I have to start it out with that equal sign, okay? I can also use these cell references. So if I put an equal sign, and then I click on this cell, notice it puts the cell reference of E3 in there. Now what this will do is it'll say, okay, go to cell E3, and whatever's in cell E3, put it here. Right? So if I hit enter here to get out of the cell, notice it just puts whatever word is in cell E3 down here in what, E8. So if I type another word right in here, because I've used a cell reference, everywhere where that cell reference was used, it should update now instead of saying hello to saying word. Right? And sure enough, it does. So you can kind of imagine, like, if I had, for example, like finance or something like that, there's some examples where, let's say you were building out like payment structure for something, and you had some interest rate that you had to use in a bunch of different calculations. Well, if that interest rate changes, you don't want to have to go through every single time that you used it and like type in whatever the new interest rate is. So you could use a cell reference where you put the original, where you put the interest rate. And then if the interest rate changes, you can just change it in one spot, and everywhere where you had it referenced, it'll automatically update to whatever that new interest rate would be. In this case, it would update to whatever the new word was. Any questions there? Just looking familiar to a couple people from ISOM, or not at all. So we've got cell references. I told you you can kind of use it to do some math for us. We also can use some built-in functions in Excel, okay? So the first built-in function we're gonna do is equals min. That tells Excel, hey, you have a built-in function called min, and it finds the minimum of a range of values. So anytime we use like a built-in formula that Excel has kind of stored in, we then have to tell it something, right? It finds the minimum of what? Well, you have to tell it, find the minimum of whatever range of values you want to find the minimum of. So we have to put a parentheses, right? And it kind of tells us, okay, just select the numbers that you want. Well, for us, they're everything from cell C2 all the way down to C51. So you can highlight these. Takes a little bit of time, right? And now if I scroll up, notice there's a formula bar here at the top, and it shows me what it's putting in the cell, but I'm going to scroll back over to show you that, okay, put then that cell reference, the cells that I selected, it just put the reference there, look through C2, and then the kind of colon here means through C51. Okay. But I didn't have to type that in. I could just select the cells there, and it automatically put those cell references in there for me. Okay. So what this should do is it should look through all these cells and return to me the minimum value. Okay. Now I could close the parenthesis here, or I don't really have to. If I just hit enter, it'll just take me out of the cell. Right? And sure enough, I made this one kind of easy because the variable was sorted. I can see the very smallest undergraduate enrollment was here at Trine University of 279. And sure enough, that minimum function identified that correctly. Okay. Any questions there? Now, one thing, I'm going to show you this, and I had someone last class where I ran into this error. So I'll mention two things, or I'll mention something along the way. But if I think, if finding the minimum was equals min, to find the maximum equals max, right? And I'm going to select the, range of values or the variable that I want to find the maximum of, just like I did before. It's just that now I'm going to click on this very first cell, and, scrolling down 50 observations wasn't too bad. But if I go over to that worksheet where I had all the universities, that's going to be a pain. There's a much quicker way to select that entire column of data, okay? So if I hold, so I've selected the very first observation. If I hold Control and Shift, and I'm holding these the whole time, and now at the same time I hit the down arrow, it sends me down to the very last row that had any value in it, okay? So if I had 5,000 observations, it would go all the way down to that 5,000th kind of row, or 5,001, right? Because there's probably a variable title in the very first one, or first cell. So that saves me a lot of time, especially when I'm working with big data sets, right? Now notice, just like before, when I select it with a mouse, and I select it using this Control Shift or Command Shift on a Mac, right? It automatically puts in those cell references as well. So there's two ways to do it. With larger data sets, it's not going to be fun to scroll down to select it. So using this Control Shift or Command Shift on a Mac and then hitting the down arrow to select the entire column, it's going to save us a lot of time. Okay. Hit Enter to get out of the cell. Now I've got my minimum and my maximum. Okay. Now, if you're not using like an actual Microsoft version, and you're doing this off of like, I don't even know what it's called because I never use it, but like Google, there's Google Sheets. Is it Google? Yeah, it's Google Sheets. So that doesn't have all the built-in it doesn't identify the shortcut sometimes. So you could still select the data using that, but if you try to use Control Shift down arrow or Command Shift down arrow, it might not recognize that shortcut. So using like an actual version of Microsoft Excel would be preferable. We'll also run into other problems if you try to use Google Sheets kind of moving forward as well. Okay. It's just limited in what it can do. Okay. Any questions up to this point? Hasn't been too crazy. Yes, we've got our minimum, we've got our maximum. Then I tell you, okay, I want you to use 6 bins, right? So we can find our optimal bin length by simply using Excel to be our calculator, right? We'll take the maximum of our data, subtract the minimum, and then divide by. Now here I've got some setting between my next sections. Hopefully I can figure out why it's making this text box bigger. But I can also type in, so I don't have to just click on them, right? So the cell that I want has the number of bins in it is I3. Okay. Now if I hit Enter here, my bin length is like almost the size of my maximum. What did I do wrong here? Yeah, right. So in Excel, just like in a calculator, we have to be really careful with order of operations, right? So sometimes I'll overkill with parentheses just to make sure that I'm making sure that it's doing what I want it to do. So here, we want to take the difference between the maximum and the minimum and then divide it by the number of bins, right? So I need to make sure I'm careful with my order of operations in Excel. Okay. Hit Enter. And now I've got my optimal bin length. Okay. So now that I've got this optimal bin length, what I'm going to do is I'm going to try to find the maximum and the minimum of all my bins. And when I say the maximum and the minimum, I kind of already have my labels typed out here. I kind of did this ahead of time because it's just not wasting time in class to typing all these out. These are just going to be labels I'm using for my graph, right? So that when I plot these frequencies, I can kind of say, okay, this is the frequency for the bin where I was counting between 279 and 12,347. Now, you'll notice each bin begins where the last bin left off, right? The only difference is here, I'm only counting it if it's less than this value, which means that the next bin, I'll count it if it's greater than or equal to, right? I can't have the equality on both sides. Otherwise, it would break that rule that we said where I could have one observation that would be counted in multiple bins. Okay, so I'm still going to use the same value, right, for the minimum and the maximum of these two different bins. It's just that on one of them, I'm not going to include the quality, and the other one I am. All right. So the very first bin will start out with the minimum value in our data set, right? So this is easy enough. We'll kind of go up here. I could type it in, but since they've already got it in a cell, I'm just going to put an equal sign, oops, and click on it, okay? Hit enter. So I'm going to start out at the minimum value. The maximum of this bin is just going to be take wherever the bin starts, which is its minimum, and add to it whatever the bin length is, right? That's kind of gives me the range of each one of my bins. So I'll start at the minimum of this bin. I can use a cell reference there. And there I didn't even click on it with my mouse. I just use the over arrow. Notice I can use the arrows to also select a cell and put its cell reference in. And I'm going to add to it whatever the bin length is. Okay, so just click on that. Now if I hit enter, sure enough, I get that maximum bin length of 12,347.33. Okay. Okay with that? Any questions up to this point? Troubleshooting, having troubles with anything I've set up to this point? It's not working. All right. So the next one, the next bin, I said always kind of starts with the last one left off. So I could just say, okay, the minimum of this bin is kind of that cutoff value or the maximum of the bin prior to it. And that's always going to be true, right? I'm always going to start the next bin with the value that the last bin left off with, right? It's just like I said, we're going to have to be careful about the equalities. Okay? So I'm going to hit enter here. Now, if I didn't show you this yet. So now we'll take it aside. So hit pause. There's something I was going to show you earlier that I forgot, and now I'll show it to you. And hopefully it'll make a little more sense about what I'm about to do next. So notice here, if I type in another word below this, when I was using that cell reference of E3, if I click on this cell, and once it becomes kind of this thick black plus sign, if I left click and drag it down, it's going to copy whatever is in that cell. However, if it's a cell, so notice like if I were to copy this down, this word, it's just going to keep putting the same word, right? Copies that word down for me. So that's kind of nice. But if it's a cell reference, like this one is, and I copy it down, what it does is it updates that cell reference by however many rows I moved it down, or however many columns I moved it over. So notice if I copy it over one column, E3 becomes F3. And if I copied it down one row, E3 became E4, right? So if I kind of use that method to copy the cell by dragging it, it will update my cell references, okay? Which sometimes is useful. And we can exploit that to save us some time, okay? So over here, right, the minimum of this bin is always going to start at the maximum of the previous bin. So if I were to copy this down one, J7 would become J8, which is what I wanted to do. I wanted to always grab the maximum of the, exactly the previous bin right before it. If I copy this down, I always want to take the minimum of the bin and add that bin length. So I7 will become I8. The problem is I4 would become I5. Right? So I can't copy that down, but I don't need to retype it because there's something that I can do, right, to make sure that I don't have to type this in once and I could just copy it down. Okay? So I always want this cell reference to update, right? When I copy this down one row, I want I7 to become I8. When I copy it down one more, I want it to become I9. Right? I always want to use the minimum of the bin. But I want this bin length to always be the value that's in this cell. So we're going to do something that's called freezing the cell reference. Okay? So all I'm going to do is put a $sign in front of both the row and the column heading. Yeah. I4. Oh, up here. as I say, make sure your parentheses are in the right spot there. It might, So I froze this cell reference, right? So now when I copy this down by dragging it, if there's dollar signs in front of the row and column heading, it won't update them. Right? It's kind of like, let's Excel know, like stay away from this. So if I copy this down one, now notice it takes the minimum of the next bin and adds to it the bin length, which is exactly what I want. So now when I copy, I can take both of these, copy them down. It's always going to use the maximum of the previous bin, and this cell will always take the minimum and add it to the bin length, right? So I can save myself a lot of work by exploiting this fact that when I copy things over and down, it'll update those cell references. And that's only because I had these columns, or I had, kind of the way I set this up was in columns, so it was kind of nice that, I always knew that it was going to grab the minimum of the bin and add to it that bin line. Yeah. So starting out right here, all I'm going to do is select these two cells. Once it kind of is this black plus sign, left click, and just drag them down. And it should kind of update all those cell references that I didn't have dollar signs around, but keep the ones J8 right here. So we're just going to take the minimum of the bin and add to it the bin length. The only thing was we had to put dollar signs in front of that bin length. So when we copied it down, we said we didn't want that to change. So putting dollar signs in front of the row and column headings lets Excel know, don't change these when I copy it down. Yep. Any other questions on this before we keep moving? Yeah. So do you have I8 here? And you've got I4 where you put a dollar sign in front of both the row and column headings. Yeah, so you can't just use one dollar sign, right? Because actually we won't really exploit it in this class. I think I'll show you like one or two examples where I won't expect you to do it, but I'll show you what it would look like. You can actually only use one, but then it like freezes the row, but not the column, which can be helpful for building certain tables, but especially starting out, I won't throw that at you at all. If we ever freeze a cell, we'll always kind of freeze both the row and the column. Yeah. You've got this bin length. It's exactly the same. Right here. This one. Are you making sure? Oh yeah, it should be. Did you type any of these numbers in, or did you select the cell references? Because if you type it in, my guess is, so this is displayed to the second decimal, right? We go to home here, and I can like move the decimal in and out with these little things. Notice it's not 0.33, it's 0.33 repeated. So if you type in 0.33 at any point and you don't use a cell reference, it'll use it should be using 0.333333, and then it would end up getting rounded up to 0.67 as opposed to 0.66. But you haven't typed anything other than cell references in? This one? Oh, what's in this cell, you mean? Yeah, so this is where, visually what you see in Excel is sometimes not what's stored in the cell itself, right? So for instance, like I just showed you, you can kind of show or change the number of decimals you want displayed, but just because I'm only seeing 0.33 here, what's actually the number that's actually stored in the cell is going to be 0.33, all the way out to, I don't know exactly, I forget the number of decimals that Excel stops at, probably like a couple hundred or something like that. But yeah, you want, that's why like using cell references is always preferable to just typing numbers into Excel. If I just wanted to type the numbers into Excel, I might as well use a calculator, right? The whole power of Excel is that it can store things out to hundreds of decimals, excuse me, and that it can update things by using these cell references. Did you get the problem fixed or no? Okay. Any other questions at this point before we keep moving? All right. So, and we can ignore this 7,500 for right now. We probably won't use that until next class. So we've got kind of where our bins start and stop. And the reason why we did this, remember, eventually we want to get the number of observations that fall in each one of these bins, okay? So we're going to use a built-in formula in Excel called Countifs, okay? What Countifs is going to do is it's going to look through a range of data, and it's going to count the number of observations that meet different criteria that you give it, like tell Excel, okay? Now, in the minimum and maximum formulas that were built in, we only had to tell it one thing, which was the range of data. A lot of these built-in functions, we might need to tell Excel multiple things. So for instance, here, the very first thing we need to tell Excel is our range of data. So, we want it to look through this variable of total undergraduates. So once again, Control-Shift or Command-Shift on a Mac, as you hit the down arrow, should select the entire column of data. Okay. Go back over, we can kind of see, there we go. Okay, so put in that range of data. So it says, okay, look through this variable. And then the next thing we want to tell it is the criteria. Well, anytime we have to tell Excel the built-in function multiple things, we have to separate it with a comma. Okay. So I select this range of data, comma. What's my first criteria? I want it to be, as the label kind of identifies, greater than or equal to 279. So I'm going to put in parentheses, greater than or equal to. That's just the syntax that Excel needs. Anytime we use a mathematical operator in these functions, we need to put it in parentheses. This lets Excel know this is not text, this isn't a number. This is like, it's looking for these mathematical operators that it's then going to use in some built-in program that we can't see. Okay. So this says if it's greater than or equal to, and you could type in here 279. However, it's going to save us a lot of work if instead of typing the number in, we use the cell reference. The only issue is if I'm using cell references in this Countifs formula, I need to use an and sign. Once again, this is just the syntax of Excel so it can identify that it's going to go and grab the number in cell I7 and use it in this Countifs formula. So the first thing it'll do is it'll go through the data, count the number of observations that are greater than or equal to 279. But we don't just want to count if they're greater than 279. We want to count if they're greater than or equal to 279 and less than 12,000, whatever here. So the next thing we'll do, and this might seem redundant, but later on in the semester, we'll actually use this Countifs formula for other things as well. And there you'll see why we actually have kind of two slots for it. But the second criteria we have is going to be, is it less than 12,347? But we have to tell it the range of data again. Like I said, I know it seems redundant, but this is just the syntax of this formula. So I'm going to just type it in. We could select the range again, but because I can see it here, it's going to be C2 through C51, right? I already knew that because I'd used it already before. Okay. And then comma, so go through the data, count it if it's greater than or equal to the value in cell I7, which is 279, and then go through the data again and make sure you're only counting it if it's less than the maximum of that bin, right? So now we'll say, is it less than, use the and sign, the maximum of the bin, okay? So this should go through and count the number of observations that are greater than or equal to 279 and less than 12,347.33 repeated, okay? So 4 things: the range of data, first criteria, the range of data again, and then your second criteria. Okay, that's kind of this Countifs formulas, the pattern of what you need to tell it. Okay? Any questions up to this point? So if I hit enter, 43 of the observations fall in this very first bin. So I could use this Countifs formula. I don't really want to type it in another 5 times. So is there something I could do to make sure that I could just copy it down? Well, if I copy it down, the cutoffs that I'm using, I7 and J7, when I go down one row, will become the maximum and the minimum of the next bin, which is exactly what I would want, right? So hell, why don't I just like copy these down? Everything looks okay. It looks like they've got a warning here, but why? Oh, well, when I copy this down, those cutoff values did update like I wanted, but I forgot that my range of data, that was also going to update, and now I'm starting to miss the first observation. And if I went down to the next row, now I'm missing the first 2 observations. So I got a problem, right? I can't simply copy this down. However, I do want these cutoffs for the bins to update, but I don't want the range of data to. So what could I do? So if I don't want a cell reference update, what did I say we could do earlier? Put those $signs and freeze the cells, right? So instead of typing in every single $sign, a nice little shortcut is if I highlight what I want to freeze, and this is going to vary on type of computer you have. So if you've got a PC, you can just hit F4. A lot of laptops, the F keys are used for multiple functions. So like on mine, I have to hold a function or an FN key and then hit F4 at the same time to kind of let it know that it wants to use the F4 key. I think what my F4 key, if I don't hold the FN key, it mutes the mic, so it has multiple purposes. So either F4, or if you have the FN key, hold FN and hit F4. Or if you're on a Mac, it's Command T. So quite a bit different on a Mac. But so that should throw $signs in front of both the row and the column heading. Okay? Now you've got to be careful. Like I said earlier, or I think it's earlier when someone asked, you want to make sure there's a $sign in front of both the row and the column heading. If you accidentally hit it twice in a row, like if I hit F4 twice in a row, notice it takes it off of the row, only puts it on the column. I kind of keep hitting it. It'll cycle through different variations until I'm back to no $signs. And then I just want to make sure that I only hit it once so that it's putting $signs in front of both the row and the column heading. Okay. Now I want to go over to my other range of data, right? I don't want that to change either, so I'll freeze that. Right. Now make sure also, I think someone had a problem in my last section. If you accidentally highlight the comma as well, it'll give you an error or just won't do it. You can only select cell references. If you accidentally select, things that are around them, it's gonna get mad. It's not gonna like that. So, any questions on this? So now when I copy this down, okay, now it looks like things are updating correctly because I'm getting the minimum, the maximum of my new bin, but the range of data hasn't changed. Okay. Now there's going to be one issue with the way that I set this one up, which is once I get to the very last bin, notice I know that my maximum value should be counted in this bin. The problem is all the other bins, the equality was not on the right side of the bin, it was on the left side. So here in the very last bin, to make sure it's exhaustive, I need to make sure that this Countifs formula, that I have a greater than or equal to sign, which is kind of identified in the label, right? So I'll have a greater than, or sorry, not greater than, less than or equal to sign. Okay? And now when I hit enter, sure enough, I'm counting that maximum observation as well. So this is kind of a weird one. You'll notice here, it probably would make more sense for me to do a catch-all category, because what's true, if I look at this frequency distribution, the majority of universities in Indiana have what? Enrollments that are less than 12,000, right? So 43 of the 50 schools in this data set are in this first bin, right? There's not a whole lot of very large universities. My guess is this is Purdue, IU, we probably fall in one of these categories, but there's not a ton of real large undergraduate enrollment schools. The bulk of the schools in Indiana have enrollments that are less than 12,000, okay? So I might want to do something a little bit different, which is what we'll kind of pick up on next class. I got a couple more things I want to show you, but I'll just kind of give you a little bit of a preview. Instead of the optimal bin length, I looked at this and said, well, this doesn't convey a lot of information to people. And so instead, I'm going to use a slightly smaller bin length, but then create this huge catch-all category here, which is that, 37,500 or greater, right? And so maybe there I can kind of pick up a little bit more of what's going on within this first bin, okay? And that's just kind of a judgment call, right? But we'll kind of work through that. I'll kind of show you some additional stuff there on Wednesday. One other thing I want to mention before we end today is it's kind of easy with this data set to look and see, okay, it starts in cell 2, row 2 goes down to 51. I've got 50 observations. So one formula that we could use to count the number of observations is called just the count function, right? So if I put equals count, and then I go over and I select Control Shift or Command Shift on a Mac, hit the down arrow, select that entire column or my entire, all my observations there. This should tell me the number of cells that have a value in it. Well, I've selected every observation, every cell should have a value. So sure enough, it tells me that there was 50 observations. Okay. Now, hopefully, I've only counted every observation once, and I've counted every observation once. So if I add up these frequencies should add up to the total number of observations, because every observation should have been counted, and it should have only been counted exactly one time. So we've got one more built-in function that we'll use, and this will kind of pop up a lot this semester, which is the sum function. All this does is add values together for you, right? So here, I want to add up my frequencies. So I actually just selected them with my mouse there. I could have done the control shifting, but I selected with my mouse. So I'll add up my frequencies, and hopefully if I didn't make any mistakes, they should add up to the number of observations of 50. Sure enough, they did. So this is like a nice check to make sure like you didn't make any egregious mistakes, right? When you're building your frequency distribution. You can use that count function to find the number of observations. And hopefully when you use the sum function, you add up your frequencies, you get that exact, those two things match up. Okay. Questions over anything there? Want to see a cell again? Or... So on Wednesday, we'll kind of finish a little bit of work in Excel. I'll then splice together what we did today and that class and kind of make like one Excel help file for that first Excel homework. I'll probably post that homework after class Wednesday, and we'll have our first online quiz kind of after class on Wednesday as well. But other than that, what should you guys have done by the end of the day today? That first SmartBook assignment, make sure you're registered. It should take 10 to 15 minutes to get through. It's created just for completion, right? So it shouldn't be too terribly tough. And other than that, I will see you on Wednesday, right? Have a good, safe weekend.